This is a brief overview of Rewired, an advanced input system for Unity. So Rewired is a new way of thinking about input. It makes some very important changes to the way input works. If you're used to Unity's input system, there's a lot of similarities in terms of how you get input. The API is written to be similar, so it's not too confusing, but there are some major concepts that are very different from Unity. So I'm going to show you how that works. The first thing we need is to have a rewired input manager. So the input manager contains all your input settings. You're only allowed to have one input manager in the scene, and the input manager, usually you're going to have one input manager for your whole game. And that's this option here, don't destroy on load here, is to make it easier for you to be able to create that one input manager and have it exist throughout all your scenes as you load new levels and such. The core of Rewired is this editor here. So you launch the editor and you get a panel where you're able to make changes to your input settings. This replaces the Unity Input Manager that you're used to here. Now you'll be doing your input editing here in the Rewired editor instead. And there are some concepts that are mirrored from the Unity system. In the Unity Input Manager, you have these what they call axes, and they are similar to what Rewired terms as an action. Essentially, an action would be any sort of action that you'd want to take based on some sort of input, like move horizontal, fire, open menu, exit, cancel. Any of those things would fall under the category of an action. So each action has a name, positive name, negative name, and then you assign a positive button and a negative button and one alternate for each. Then you have some options for keyboard digital axis simulation here. And then you have the ability to choose to assign this action to a specific joystick by ID on a specific axis by index, or if you want to assign it to a joystick button, you have to type the specific button here, and it's kind of difficult to get it right. If it disappears, you didn't get it right. There you go. See, so that's how you assign a joystick button to an action in Unity. It just doesn't work very well. There's a lot of problems with this system here. For one, if you're making a multiplayer game, say you're making a 2-player or 4-player game, and you have move horizontal. You want the move horizontal to move player 1 left and right. What about player 2? You have to make another move horizontal for player 2, and another move horizontal for player 3, and another move horizontal for player 4. Say you're making an 8-player game. There's 8 copies of every possible control for every player, plus you have to all assign them in a static way. These assignments are fixed. They're not runtime modifiable. So you're assigning an action to a specific joystick on a specific axis or button ID that can't change. So your Unity's input system is based on fixed device IDs, fixed axes, and fixed buttons. Rewired, on the other hand, is completely different. It completely changes the way this works. Instead of relying on getting input from a fixed joystick, or even getting input from a joystick at all, you get input from a player. So how this works is a player is assigned a joystick or a keyboard or a touch controller or a guitar or whatever kind of input devices you have. You have all these devices plugged in, and you assign the devices you want to the specific players you want. Now you get your input from the player instead of the device. On your scripting side, you don't even have to care what devices the player has when you're getting input from it. You just say player get axis move horizontal. And whether it's a keyboard or a joystick or a mouse or a touch controller, anything that gives back data for move horizontal goes through player and to your script. There's also another great advantage in that you create one action one time for as many players and devices as you want. So this move horizontal, instead of creating 8 copies of move horizontal and 8 copies of fire and 8 copies of jump, you create an action. This is how you edit actions in Rewired. They can be categorized and such. We'll go over that in a while. But you create an action, you give it a name, and you can give a descriptive name if you want. Choose its type. Give it names for positive and negative sides. And now that action can be assigned to any controller, keyboard, any sort of input source, and it can be reused on all the players. You created the action one time. That's it. So how you would go about doing that, I'll just quickly show you, is the concept. I'll go over maps in a while, but you would create a map for a gamepad here, add an element. Let's say left stick X is move horizontal. Now for any of these gamepads, any of these supported gamepads that fall under the dual analog template, left stick X is now move horizontal. So the next step would be to add that, create a player, so that then assign him the joystick map. So our joystick map was in the category default, layout default. Now this joystick map, which we've created with left stick X move horizontal, any of those controllers, when they're plugged in and assigned to this player, and the player presses the left stick, you will get a move horizontal action. That's it. If you want to do it for keyboard, you would create a keyboard map, assign, let's put A as move horizontal, move left, so change it to negative. Copy that, make D move horizontal positive. So now A is move left, D is move right. Again, we assign that map to the player. Go back to your player 0, keyboard maps, add a keyboard map, and that's the keyboard map. Make sure it's enabled. And now on the keyboard, A is going to move horizontal left for player 0, D is move horizontal right. Very simple. You can do that for 20 players if you want. For a joystick, for this joystick map we've created, we could create more players, add that joystick map to each player. Any of these players who uses a dual analog gamepad, left stick X means move horizontal. The player-centric nature of Rewired makes it so that multiplayer games are not a problem anymore. You don't have to fight with the input system anymore to make a multiplayer game. Alright, let's just quickly go over some more of the features of the editor here. So let's go page by page. Just real quickly tell you how things work here. On the settings page, you have global settings that you can set for Rewired. So the first setting is the update loop. This Rewired allows you to update your input in any of the Unity update loops, update, fixed update, and on GUI. Input can be updated in one update loop or multiple simultaneously. So if you need to get input in the on GUI loop, you should enable on GUI, and then input will be updated specifically for the on GUI loop so that you can get things like get button down and they will work correctly. This next section here allows you to choose your input sources. This first option, XInput, is available on Windows and Windows Store games. And it will use XInput to control XInput compatible devices such as the Xbox 360 controller. If you don't want to enable XInput uncheck this box, and on Windows it will use Direct Input for all devices. If this box is checked, it will use Direct Input for devices that are not XInput compatible and XInput for XInput compatible devices. There is one limitation you should be aware of with XInput. It only supports up to 4 controllers at once. When XInput is enabled, you'll be able to add as many direct input controllers as you want, but if any of those are XInput controllers, there's a limit of 4 of those. This is a fixed limit in XInput. The next option, always use Unity input, is there to allow you to disable any native input sources such as direct input or XInput. With this option checked, it will always fall back to Unity input. So therefore, certain features that are not available to Unity inputs will not be available if you check this box. Now let's look at joystick auto assignment. This is one of the key features of Rewired. This is where you change your settings on how joysticks are assigned to players. So if you enable auto assign joysticks, when you plug a joystick in, or when you start the game with joysticks already plugged in, it will automatically assign to each player a certain number of joysticks as you specify. This is also where intelligent hot plugging comes in, where when you disconnect a joystick and plug it back in, it's assigned back to the correct player. You can change those settings right here. Alright, let's look at players. I already showed you a little bit about players earlier. So in order to get input, you have to have at least one player. You create players here from the players page, and there's always a system player by default. This system player is useful to help you do system type of actions like, say, opening a menu or save game, load game. Actions that shouldn't belong to a specific player can belong to the system player. The system player can be assigned joystick maps, keyboard maps, mouse maps, custom controller maps, just like any other player. So when you first set up your input for your game, the first thing you'll want to do is to come in here and create players for each of the possible players in your game. From this page, you will be able to create a player, name the player with a friendly name if you want to display that to your players. You can choose whether the player is playing on start or not, and this mainly affects whether joysticks are auto-assigned to them. You can choose whether the player starts with access to the mouse, and you can assign maps to the player for each type of controller. You can also add custom controllers to this player. Custom controllers will be explained later. Let's look at actions. So I've explained actions earlier. This is where you edit your actions. You can create new actions, insert, duplicate, delete, reorder your actions as you see fit. Another important feature is that you can categorize actions. Go over to action categories here, or from the actions page, click edit categories, and you're able to create categories where you can organize your actions. So this can be used for a variety of purposes. I'll just show you an example of a style of game that maybe has different game modes, like say it's a first-person shooter and you're allowed to run around on foot. You can get in a vehicle, you can get in an airplane. You could use categories to help organize those sets of controls. So you might make a category for gameplay shared. Say this category would have all the controls that are shared among the different modes. You have a movement maybe, or a fire button that has to be used on all those modes. You could stick it in here. You could create another category for infantry mode. You could create another category for, let's just say, vehicle. And another category for airplane. There are other cases where you need to categorize sets of controls that are not related directly to gameplay, like, say, menu controls. Go ahead and make a category for that. Now when you go back to your actions page, you get a list of categories here. You can create for each of these categories your sets of actions. So say gameplay shared, we want to have fire. Okay, and now for infantry, maybe infantry has different sets of controls. He needs a jump action. For vehicle, you might have accelerate and brake. And for airplane, change altitude. Say it's a VTOL type of plane. Or eject. Then for menu, you might want something like confirm, cancel. This is just to give you the idea of that you can categorize your actions based on how you want to use them. Then if you were to be making a map, you can choose from your categories to find the action you're looking for. Say you wanted to add a fire button. Add a new element. Choose the button you're looking for. Choose the category. Fire. Another feature related to actions is input behaviors. So we've set these actions up, and there's this option here for input behavior. Right now there's only one input behavior called default. Let's go over to the input behaviors page. Input behaviors allow you to change the way an action behaves. You can see various properties for the action here. Some of these properties are mirrored from Unity's input system, such as the digital axis properties. These digital axis properties allow you to simulate an axis with a button, or in most cases a keyboard key. So you press A to walk left, D to walk right. If you want that action to gradually accelerate and decelerate, you can change those settings here with gravity sensitivity. There are other properties you can change, such as how mouse axes are treated, and a button double press speed. This allows you to detect double clicks easily, and you can set the speed for it. Each of these has descriptions on mouse over. The nice thing about input behaviors is you can create more input behaviors, set your properties how you want them, and then assign that input behavior to an action. So the input behaviors can be shared among different actions. So you don't have to duplicate all that information as you would in Unity's Input Manager. Another important and unique feature of Rewired is controller maps. Controller maps map actions to elements on a controller. An element could consist of a button, an axis, or a keyboard key, or a touch screen control. Any sort of element can be mapped to an action. Rewired allows you to create maps for joystick, keyboard, mouse, and custom controllers in the editor. Similar to action categories, map categories help you organize your maps into logical groupings. In addition, map categories can be used to help determine whether an action should be assignable by players or not in user mapping screens. It also has options for helping with joystick element conflict checking. Let's create a few categories to show you the concept. Just like with the action categories, these same groupings may be useful for organizing maps. Let's recreate them as map categories. When we create our joystick and keyboard and mouse maps, we'll be able to assign them to an appropriate category. A second level of map categorization is layouts. You can create different layout groups for joysticks, keyboard, mouse, and custom controllers in the editor. A layout has a variety of purposes, the most obvious of which might be to have alternate layouts for controller maps. Say you have a game and you want to give the player an option of choosing from various predefined controller layouts. You might have default, classic, left-handed, etc. You can achieve this through using layouts, but that's not the only use for layouts. Layouts can be used for many other purposes. Let's create a couple of layouts. Unlike map categories, you can create different layouts for each controller type. So if we look at joystick maps as an example, we have the map we created earlier. Now you can see in the categories section, the categories we created are listed. If you see an asterisk next to a category, that means the category has a map created inside it. Let's delete this map that we created in the default category and create new ones in the new categories we created. Create a map in the gameplay shared category. If you want to add a single element, click New, and it will add an element which you can choose the particular element from the list here. Or if you'd like to add all possible elements for your selected controller, click Create Defaults. It will create a list of all the elements that you can assign. For now, we'll just create individual elements because we don't have that many actions to assign. So create a new element, select the element source. Since we're mapping the dual analog gamepad template, the element names are a little bit generalized. We have action bottom row 1, 2, and 3, etc. On the game side, these elements will be mapped to the name specific on the controller to which they are mapped. If you want to display the name of the element to the players, it will show the proper name for the particular joystick they're using, not this generalized name. Since we're going to map the fire button, we'll put it on the action bottom row 1, which corresponds to the 4 or 6 buttons accessible by the right thumb on the gamepad. Now choose the action category, and the action itself is fire. So now we've assigned fire to the action bottom row 1 button of the dual analog gamepad template. Axis contribution is a setting that allows you to change the value the element gives to the final action axis value. So say you want this button to apply a negative value to the final axis value of this action. You can set it to negative. This would not be useful for a fire button, but it would be useful for a button being used for one side of a particular axis, like say move up and down. If you wanted the button to move the character down, you could set the axis contribution to negative. Let's create maps for each of the other categories. This would be more appropriate on maybe the trigger button. Left shoulder 1. We can duplicate that. Change it to right shoulder 1. Put brake. Be better to switch those two. Alright, now for the airplane map. Change altitude, we might want that, say, on the right stick Y. You can invert the axis here. You can also choose whether you want the axis range to be just one side of the axis or the entire axis. If I chose positive, then only right stick at Y positive would change altitude. You can also set the axis contribution for that. So if you wanted right stick positive to make the altitude go down, change it to negative. So you can see here that changed. Right stick Y positive equals change altitude negative. That doesn't make sense here, but you could still do that for other purposes. Let's change this back to using the full axis range. Create one for eject. Let's put that on left stick button. So these maps we've created were in the default layout. If you wanted to have an alternate layout, such as classic or left-handed, you would create the maps for these particular layouts by selecting them here, then creating the map. We'll skip doing that for now. Then when you assign the maps to your player, go over to your players, choose joystick maps. In order to assign the particular map as a starting map to your player, choose the category and layout of the map here. Let's assign gameplay shared to the player. We'll use the default layout and make sure start enabled is set so that this map will be loaded when the player is created on start. Let's add the other maps we created too. Infantry map. We'll leave the infantry map enabled on start as well. We'll add the other two maps, vehicle, airplane. Let's disable vehicle and airplane on start because our player is not going to start in a vehicle. When he enters a vehicle through scripting, you can switch which maps are enabled and disabled. We'll also add the menu map. To understand a little more about how maps are processed, you can go check the help from Window Rewired Help Documentation and look at the controller maps page. It explains controller maps and has a chart here to visually show you how maps are processed from each controller. This example shows a player with 4 controllers assigned to him: an Xbox 360 controller, keyboard, mouse, and a custom controller on-screen joystick. Each controller has 5 maps of the categories we created. We've chosen to disable certain maps based on the current game mode in this example. There's a menu map which is disabled, a gameplay shared map which is enabled, infantry is disabled, vehicle is enabled, airplane is disabled. So this would be for during gameplay when your character is in a vehicle, the vehicle map and the gameplay shared map are currently enabled. All the other controls on these 3 other maps are disabled and will not affect anything. In terms of your scripting, all you do is call player get button fire, and based on which maps are enabled, you will get a result. This allows you to create complex control systems for any style of game. So for keyboard maps, layouts might be used for a different purpose than they were in the previous example. For the keyboard, layouts could be used to separate control sets for different players. Let's create a few layouts for the different players. So now we have these player layouts. Now let's create some keyboard maps. So let's get rid of this keyboard map we created earlier. So let's map the fire button for gameplay shared for player 0. So select your category, select your layout. Create the map. Choose a key. We'll go for left control. And then you can also assign modifier keys such as Control Alt Shift. You can have up to 3 modifier keys in order for this action to take place. We're not going to do that here. But so then choose your action category. This is the gameplay shared category. Let's choose fire. So now left control will be fire for player 0. Now on the infantry map, create an element to assign jump to. Let's put it on space. Action category, infantry, jump. Now space will be jump for player 0. You would do the same for the other elements. And assign them their keys. So let's create another set of maps for player 1. Maybe right control is player 1's fire button. Let's put jump on right shift. We'll put these on page up and page down. For change altitude, we'll actually have to make two, one for positive and one for negative. So we'll put the positive on keypad minus and the negative on keypad plus. So now we need to change keypad plus axis contribution to negative, so it's down. So now we assign for player 0 and player 1 their keyboard maps. Currently we have the default keyboard map that we made earlier assigned, which is no longer valid. Switch the category to gameplay shared, switch the layout to player 0. Now we'll add another keyboard map, infantry, player 0. Another keyboard map, vehicle, player 0. Another keyboard map, airplane, player 0. And the menu map, which we actually didn't create, but now again, disable the maps that you don't want enabled on start. We'll assume we're starting in the infantry mode, so we'll disable vehicle, airplane, and menu. Do the same for player 1. And now we have two players assigned to the keyboard with their own sets of maps, which can change based on the current game mode. This kind of very complex input scheme is quite easy to achieve using Rewired's mapping system. The best thing about Rewired's mapping system is that it's runtime modifiable and you can save it and load it to and from XML files. An included example in the Rewired folder is the controller remapping 1 example. This shows how you can create a controller remapping screen for your players. Now this remapping screen isn't meant to be dropped into your game and used as is because each game has its own needs for controller mapping. You may be making a 1-player game or a 4-player game. It might be a fighting game or a flight simulator. The controller remapping needs vary depending on your game style. In the future, I may be including some default mapping screens for various types of games to make it easier for you. You can look at the source code of this example to learn how to create your own controller mapping screens and customize this one to your needs. Let's take a look at this example here. Let's press play in the editor. If I press ESC to open the menu, you can see this example shows you how to map different controllers to different players. You can assign the mouse. You can assign actions to elements on the keyboard, the mouse, or controllers in the different categories that we've created. Now this example uses Unity's legacy GUI system. Obviously, you wouldn't want to use this in your final game. There are many GUI systems out there that you should be able to integrate into Rewired's user mapping screen. When Unity 4.6 is out of beta with their new UI system, I'll be adding some more examples for that. But let's just show you how this works quickly. We've got our different players we've created here. We can select among the players. And each player has already been assigned a joystick. You can see player 1 was assigned the Cytec P990. Player 2 was assigned the XInput Gamepad 1. So if we take a look, you see a list of categories here. These are the categories we created before, except for general. It's slightly different because these are from the example file. General represents what we were calling gameplay shared previously. So you can see for the selected controller is the keyboard, and these are the elements assigned to the actions for player 1. Tab is assigned to toggle minimap. Zoom in minimap is right bracket. And then if we select through the different controllers, you can see you're able to assign elements for each controller, for each category, for each player. The P990 already has some assignments. We've got left stick XY, button 4, D-pad down. Same thing in here, infantry, vehicle, airplane. With Rewired, you're able to assign as many elements to an action as you want. I'm going to add an element to this action here. If I press right on the D-pad, you'll see I have assignment conflict. D-pad right is already in use. You may replace the other conflicting assignments, add this assignment anyway, which will leave multiple actions assigned to this element, or cancel this assignment. So Rewired includes some functions to help you with conflict checking so that you're not having the issue of two controls being assigned to the same element. So let's go ahead and replace this. It will remove, you saw one disappear down here. Look right used to be D-pad right. Now I put replace and it added D-pad right to zoom in minimap. I could do that with as many as I want. I could make D-pad up, D-pad left, D-pad down. You can see there's no limit. Obviously, you have a practical limit of screen space on your mapping screen, but that's just a matter of your mapping screen design, how you're going to deal with that. You could limit the user to 2, 3, however many you feel is necessary. You can do the same thing for keyboards. We could add 7, 8. We could change this existing one, reassign this to 9. You're able to assign multiple joysticks to one player if you choose to. I just took the joystick away from player 1. Now they're both assigned to player 2. Any player can have as many number of joysticks as you choose. Again, whether or not you allow the players to do that is up to you. All of this information can be saved and loaded to and from XML files. So you're able to allow your players to save profiles and change their controls, and the next time they play, their control layouts will be as they left it. You can also see the naming of the elements is specific to the controller. These two controllers, on this controller, action is on B, fire is on A. On this controller, it's button 3, button 2, because that's how the controllers are labeled physically. So you're able to show your players the actual names of the buttons for supported controllers. These could also be used like on a help message during gameplay. Hold X to pick up item, something like that. Another important feature is calibration. You're able to calibrate axes on joysticks to help with problematic controllers. So say some controllers, maybe the axis is mapped as -1 is the default state of the axis. That's fine. You can go ahead and you can set your min and max value for X. Set your min and max, record your min and max value for Y. You can set your 0 state, you can set your dead zone and invert state for the axes. The implementation can change. This is not fixed. This is just an example in this control remapping screen, but all of those functions are available in the API for you to achieve this. You could certainly make a visual axis calibration screen if you wanted to. In order to see all the inputs and how they were set up in the control remapping demo, just click on the Rewired Input Manager and launch the editor. And you'll be able to look through how the players are set up, how the actions were created in the different categories, how the joystick maps were created. You can check the mapping categories, how conflict checking is set up. There's some special conflict checking stuff going on with the different categories. So you're able to have some categories conflict checked against other categories selectively. And you can also see there are some protected controls here. The system category was not displayed to the users, and there are system controls set up for keyboards, such as escape, opening the menu, displaying frame rate, load, save, quick load. None of these were mappable on the mapping screen because of the settings here, not user assignable. So there are some very powerful features in Rewired that allow you to create a custom setup specific to your game's needs. I just want to quickly look at custom controllers. So there's another example here called Custom Controllers Touch. Let's open that. Close the editor. Alright, so if I press play, Custom Controllers Touch is a simple example showing you how you can create on-screen touch controllers using custom controllers and still be able to use all of the features of Rewired, such as the actions, the categorized actions, and all of those things. The way this works is a custom controller is essentially a virtual controller that uses any input source that you can feed it. So in this case, these scripts here, touch button example, touch controller example, touch joystick example, the button and the touch controller are feeding the custom controller axis and button value data as they're updated from the screen position. So in order to set up a custom controller, you go in the editor and you first create your custom controller here in Custom Controllers. So you would create a controller with a name and however many axes and buttons as you need, and assign properties to those axes and buttons as needed. Then you could create custom controller layouts just like the other types of layouts. Then you would create a custom controller map. It works the same way. You choose an axis, you choose a button, you assign an action and properties. Then on your player, you add a custom controller here, starting custom controllers. You add the controller, choose the controller that you've created, and you can even tag it to make it easier to find in scripting. Each of these players has that custom controller assigned to them, and these will be created on start. To see how you actually implement the custom controller in scripting, just look at the source code of these examples here. It's essentially a matter of registering for an event so that you can update the input source at the right time. You're setting the axis and button values in the custom controller. Rewired allows you to create your own controller definitions if you choose to do so. It has an editor for creating hardware joystick maps. It also has an editor for the template maps. These are fairly advanced concepts, and generally for most people I would recommend that you don't create your own controller maps, but the ability is certainly there for you to do so if you want to. There are also some tools it comes with to help you identify your joystick elements when doing custom controller hardware maps. In future updates, I will be adding support for more controllers than the ones it comes with in the original release. I hope this overview helps you understand what you get with Rewired and how it redefines controller input in Unity. Check out the other videos for details on specific topics.